Today we're going to do algebraic proofs. So you should be able to solve this the way we did algebraic solving equations at the beginning of the year. So, by the way, Monday you should have crossed it out. Tuesday we had a warm-up. Wednesday you should have put PSAT. Thursday you should have written yesterday's warm-up, and then today is today's warm-up. So, now, when I'm solving this, let's focus. When I'm solving this, what do I do first? PEMDAS parentheses, yes, 2 into the parentheses is distributing. 2 times x, 2 times -3, -6, bring down 3x plus 15. Okay, x is on both sides, so I got to get rid of the smaller x. Which x is smaller? The 2x. How do I get rid of a 2x? Minus 2x. Sorry. 3 minus 2x is what? So we brought down -6. 3x minus 2x is a 1x, or just x. Bring down 15. And then to get rid of the plus 15, what do we do? Minus 15. You can put 1x, but in the end, it's the same thing as just x. -6 minus 15 is -21. And that's it. Okay? Now, your warm-ups should be done for the week. You can go ahead and pass those to the front. And I'm going to pass out your notes that we're doing today. So again, we're checking for names on these warm-ups. No name. Is this yours? Okay. Okay, so we're going to look at these notes that you should have starting right here. Everyone has this? All right. Okay, so I want everyone focused without headphones in our ears. Thank you. So, on properties. Now, the objective was that we're going to be able to solve algebraic proofs. And so to do that, we need to know our properties. So this stuff is kind of obvious, but we got to know what it is. So when you add on both sides, that is called the addition property. So if A equals B, A plus C equals B plus C. All that means is if you add a number on each side, it's going to stay equal. Okay? If we subtract on each side, it stays equal. So the subtraction property is A minus C equals B minus C. Now, if this doesn't make sense yet, it will when we go to the back. I'll show you an example. Okay? Now, if we multiply on each side, that's called multiplication. Multiplying on each side. 8 times C equals B times C. AC equals BC. And what do you think about dividing? All right. What are you listening to? Really? Then take it out. Please. I appreciate it. Say it again. All right. Do you think that was a good thing to say? Think about what you say. Next thing, division. If you divide on each side, A over C equals B over C. That's the division property, stays equal. And we know the distributive property, we did it on the warm-up, right? A times B, A times C. So AB plus AC. Now this is all stuff we know. All the operations and distribution. Do we know how to combine like terms? We know that's a property. Here's an example. If I have 1A plus 2A plus 3B plus 4C, okay, which one of these can actually combine? Only the A's, right? So that'd be 3A. Okay, so part of our logic unit is going over proofs. You got to be able to prove things, so yeah. So hopefully this will be easy because you already know how to solve. You just put your reasons off to the side. So it shouldn't be too bad. Substitution is replacing, right? Replacing values. Okay. Now, reflexive property. This is probably new to you. Bless you. Reflexive is kind of obvious. It's when something equals itself. So A equals A. You don't use it all that much, but if you ever need to use something like that, A is equal to A, that's reflexive. Symmetric, do y'all know what symmetry is? What's that? Same on each side, okay. So like on a picture, you could fold it in half, and it would be the same, right? So if something is the same on each side, if A equals B, then I could flip it over and B would equal A, right? B equals A. Symmetric property is just flipping it over, right? Now, transitive, okay, if A equals B and B equals C, that means that A skips over the B and is equal to C. A equals C. Okay, so it's like if Mr. G equals your teacher and your teacher is the coolest in the world, then Mr. G is the coolest in the world. Yes, sir, that's right. Yes, sir. Now, down here, it's the same for figures in geometry, notice these down here have, instead of an equal sign, they have a congruence sign, which is different. Okay. Reflexive property, A is congruent to A. Same thing, right? Symmetric property, A is congruent to B, then B is congruent to A. Okay. Transitive, if A is congruent to B, B is congruent to C, again, A is congruent to C. Okay, now at the bottom, talk about proofs. Proof is a logical argument that shows a statement is true. And we're going to be talking about two-column proofs. A two-column proof are numbered. Okay, steps on the left and the corresponding reasons or justifications on the right that show an argument in a logical order. When we write proofs, we always write the blank first. Now this is very important. Given is always first. You're going to be given information, and that given information is always the first step. Okay, they give you your first step. Write this down. And then what do you end with? Well, there's going to be it'll tell you what's given, and it'll tell you to prove something. So the last statement is what you're trying to prove. Okay, this is grammatically not right, but again, the last step is what you're trying to prove. Okay, always be what you're trying to prove. And what do we use to do proofs? Definitions, theorems, postulates, and properties. Okay. Postulate, these are all kind of the same thing. Like definition defines something. Theorem is something that we conclude. Postulate is another thing we conclude. Properties are things that are true about something. So these are just things we know that we're going to do step by step. So flip it over. Now, no. Flip it over. Now, this might look hard. This is the training wheels section, okay? Because it gives you steps along the way. But if you could do the warm-up, even kinda, you should be able to do this. So let me show you, all right? Step one is always what? Step one is always what? Given. So again, it says it right here. That's your first step. I wrote this right here. And my reason one is given. Always given first. Always. Okay? We will have a test next Thursday. Now, number two, what do I do first on the left side? There's a number in front of a parentheses. I need to do this thing, which is called what? Distribution, distributive property, right? So I need to fill in this blank by distributing. 2 times x, 2x. 2 times negative 3, and then equals 8. Okay, so if you were solving this normally, that would be your first step, and that's the reason why you did it. Now, step 2 to step 3. What would you get rid of first on the left-hand side here? How do you get rid of a negative 6? Plus 6, plus 6. And then over here, 8 plus 6 gives me that 14. Don't say that word. Now, what did I just do on both sides? Addition. So what should I write? Addition property. Oh my gosh. Okay. Now, last step. 2x, how do I get rid of that 2? Divide by 2. Divide by 2. X equals what? 14 over 2 is 7. And guess what? That's what I was trying to prove, right? The work is what I'm grading, right? So they always give you the beginning, they always give you the end, and these are notes. So to finish my sentence, though, they always give you the beginning, they always give you the end, and your work is to prove the middle part, okay? How do I get from point A to point B? And the last step was dividing, so that's why it was division property, okay? Now that was with training wheels, because they gave us some steps. Stop. Please stop saying that. Okay, number 2. Now, first step is always what? Given. Now, it already says given, but we're going to write this thing right there. 3x minus 4 equals sign 1/2 x plus 6. You always are given the first step, so you're always going to write the first step, right? Now, real quick, x is on both sides. What do I need to do when x is on both sides? We need to get rid of what? Well, first start with the x's. Get rid of the smaller x. Step 1. How? I know, but I'm saying, how did I get from step 1 to 2? What did I do? So we get rid of the smaller x. Do we agree? Okay, let's start over. When x is on both sides, we get rid of the smaller x, right? So the smaller x is 1/2. So write small, minus 1/2 x, minus 1/2 x. 3 minus 1/2 is 5/2. Okay? So what did I just do that I need to write right here? What is this? Subtraction. So I need to write subtraction property. Property. Yeah, I'm going to abbreviate prop. Now, step 2 to step 3. Right? 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 So, what do I get rid of next over here? The minus 4. How do I get rid of minus 4? So what do? Okay, I add 4 to both sides. So 5/2x equals 6 plus 4? 10. Now look at step 3 to step 4. All that happened was 5/2 went away. Now let me ask you, how do you get rid of a fraction? Multiply by what? What? Same thing? No. What? What? You flip it. What's that called? What do you call it when you flip a fraction? Start close. It starts with an R. Reciprocal. Y'all heard that word before? Reciprocal is when you flip a fraction. So we're going to multiply by flipping 5/2. What's that going to be? 2/5 on both sides. When you multiply by the flip, it cancels out the top and the bottom. Now I just have x. And then 10 times 2 divided by 5 is 4. Okay? So what did I just do on each side? Multiplied. So I'm going to write multiplication property. Sometimes I like to abbreviate. What? Prop. Okay, 3. What is... True. It's just the reasons. Now, what is always my first reason? Given. Now, that's going to be on a test, and someone's going to put something else for number 1. But I keep saying it, even to be annoying, that first step is always given, right? Now, step 2. How do I get rid of these parentheses? Okay, so 8 times x is 8x. 8 times 2, 16. What's that called when you multiply into a parentheses, though? Distributive property. Distributive property. Now, step 3 is already all the way done, but do you agree that they got rid of the smaller x? Minus 5x, minus 5x. 8 minus 5 gave me this 3. Cool. Now, looking at step 3, how did they get rid of the plus 16 there? Minus 16. Minus 16. 7 minus 16 is negative 9. Cool. But what did I just do on each side? Subtraction. Minus 16, right? Now, do you notice how it's... I know, but each step we just did 2 subtractions in a row, right? Do you see it right here on step 2 and step 3? That's fine. You can do the same thing twice as long as you're solving it. Now, on step 4, how do I get rid of this 3 right here? Divide by 3. Divide by 3. So that's division, right? Because we just divided. Division property. Okay, now this is weird. Step 5 and step 6. What happened from step 5 to step 6? All that happened was a flipperoo. Now, what do we call that when it's the same on each side and you just flip it over? Okay, it's on here, but you got to know this. Symmetric is when you just flip it over. Now, why did they flip it over? We want x to be on the left. Okay, so again, when you're solving, you can solve for x on the right, but your last step, flip it over, put x on the left, okay? Because we want to know what x equals. All right? Now, if you thought that was hard, go to the next page. What is this? The training wheels are off, but guess what? You know how to do it. All right, you can do it. Step 1 is what? Given, yeah. What's step 1? 5x plus 10 equals 3x minus 2. What should I do first? Distribute, right? 9 what? And then 3 times negative 2? Negative what? 6. 5x. Bring this down, right? And what was the reason again? Oh, I just distributed, so it should be the distributive property. X is on both sides. What should I do? What should I do? I don't combine unless they're on the same side. They're on different sides, so what do I do? Minus 5x, yeah, smaller x. So 10 equals what? 9 minus 5. 4x, bring down minus 6, and what did I just do? Subtraction property. Okay, number 3, I need to get rid of that minus 6, that loner. How do I get rid of minus 6? Plus 6 on both sides. 10 plus 6? 16 equals 4x. What did I just do? Addition property. What did you just say? We got to get rid of this 4 by dividing. So this is step 4, and now we're going to divide to get step 5. So 4 equals x, right? What do we just do? Division property. Now 4 equals x seems done, but remember, x needs to be on the left, so we're going to flip it, yes. X equals 4. Symmetric property. Who said give up? Oh, okay. I want you to try 5 and 6 and see if someone can do it on the board. Who wants to do number 5 on the board? Who said that? Let's do it. What's this? Given. First step is doing what? Real quick. Distributive property, right? Distributive property. Get rid of the smaller x. Now, if I just subtract it on each side, I'm going to put what? What? Subtraction property, right? Did you finish? So, subtraction property. And then to get rid of the to get rid of the loner, adding 2 on both sides. That was addition property. And then to get rid of that 3, we divide. So that was division property. Now, 10 equals x is cool, but we want x on the left side. X equals 10. Flipping it over is symmetric property. up? What about these reasons? What did you just do here? So what did you just do on the side here? Okay, so what do you write here? Sub prop. That's fine. And the next time, what did you do? You did what? Addition prop. And then the next thing you did, dividing prop. Sorry. And then, hold on. You mean x equals 3. You had to flip it over. So what was that? Symmetric property.